every day you and I get bombarded with negative news. Just like the body becomes what we eat, the mind becomes what we're putting in. It is important to listen to stories that not only gives you hope, but also inspires you and uplifts you. In this podcast, we're interviewing experts who will break down the solutions to the world's most pressing problems. And I promise you, if you listen to this podcast, you will not only stay informed, but you will also feel more energy in your life. Welcome to Great.com Talks with. Great.com is a philanthropic project where we're donating 100% of the profit towards the most effective cause areas like protecting rainforests, funding climate change technology. The best thing that you can do to help in our mission would be to subscribe to the channel. The topic of today is climate change and NASA. And our guest today is Dr. Robert Cahalan. Dr. Robert has been doing scientific research for the last 40 years. And right now, Dr. Robert is working at NASA Goddard Space Flight Center. Robert's specific scientific interest is within climate change, energy balance, remote sensing, and solar radiation. And in this interview, Robert and I will speak about the work that NASA is doing and has been doing when it comes to climate change. You will also hear Robert speak about the importance of hope. And Robert will also share his mindset when looking for solutions for global warming. Robert, welcome to this interview.
I'm very pleased to be here to discuss climate change and other activities of NASA.
Yes. So help us understand when it comes to the work that you're doing at NASA and the work that NASA is doing overall in the help of climate change, what role is NASA playing for humanity right now?
So I think what NASA has brought to us from early on in the beginning of NASA, which began around 1960, and especially with Kennedy's challenge for NASA to go to the moon in 1962. And in getting to the moon, one of the first things we did was we looked back at Earth, and there's a famous picture which is seeing Earth rising over a terrain on the moon with the moon's various craters and no atmosphere, so you can very clearly see the Earth and the beautiful clouds and oceans and the Amazon rainforest and other features of the Earth, the ice caps on the pole, North and South Pole, and so on. First of all, just seeing the beauty of our planet and seeing the contrast between, realizing Earth is a planet. Earth is not flat. It's the first time we directly saw that, and everyone on the planet could see, and everyone is thinking together, wow, that's where we all live. And then looking down at the earthscape, the moonscape, doesn't look like a friendly place to live. No atmosphere. The hot side of the moon gets very hot. You have to have a spacesuit there to protect you from the heat. And the sun is up for 2 weeks there on the moon. And then there's no sunlight for 2 weeks as the moon orbits around the Earth in 1 month. I personally would not want to go there. Astronauts go there and they're very courageous. But I wouldn't want to spend any time there. I prefer the Earth. And NASA does a lot about the Earth. NASA currently has 35 active missions studying the Earth and sort of keeping the pulse of the planet. What's going on with the Earth? Where are the people? You can see those in the night images that NASA makes. Where are deserts growing? Where are there floods? Where are the hurricanes? How is the ice doing? Is Greenland melting or not? We look at all those things. So there are 35 missions about the Earth. NASA also has 25 missions about the sun. And that's also been an interest of mine is global warming due to the sun brightening up? Well, that's true. That happens every 5 or 6 years, the sun brightens up. And then another 5 or 6 years, the sun cools off again. And that does influence the temperature on the Earth. So that is one of the things that causes Earth change. But now we've been looking at the sun and monitoring that 11-year cycle for 40 years. And there's no upward trend in that. It goes up and then it comes down again. Then it goes up, comes down again. So there's no overall trend. The sun is not causing global warming. That's what we conclude. And I think that's good news, because if the sun was causing it, how would we fix it? So it turns out we humans are causing it. We monitor the CO2 in the atmosphere. That goes up and down seasonally too, every year, up and down, up and down. But when it comes down, it's always a little higher than the previous time it went down. So there's an overall trend. And we know what that's doing to the atmosphere. It's warming the atmosphere. And then we get more water vapor in the atmosphere, and that warms even more. A warmer atmosphere holds more water vapor. So, and the water vapor is further warming. So there are these feedbacks, and I've been studying that for now, as you said, about 40 years. Actually, I've been doing science research for more than 50 years. But most of that time has been studying the Earth and what's going on the Earth. So the 35 missions for the Earth, 25 about the sun. There's 21 missions that have to do with other planets, like the one, the study of Mars, which is going on by the rover that just landed last week on Mars, and the little helicopter it carried with it, which will drop out of its belly soon, and the rover will drive a little bit away, and then the helicopter will fly around, take pictures of the rover, and the rover will take pictures of the helicopter. And that's the first ever controlled flight on any other planet besides the Earth. So that's exciting. Then also there are 13 missions about the universe as a whole outside of our galaxy, outside of our solar system, in the rest of our galaxy and all the other galaxies. There's only 13 missions, but those are big missions. One of them will be at the end of October this year, when NASA will launch the JWST Space Telescope, James Webb Space Telescope. That telescope will have to fly by itself 1 million miles outward from away from the Earth, 1 million miles away, and then deploy its big 5-level umbrella to protect itself from the sun, and then gradually turn on all of its telescope and instruments and start looking out at the rest of the universe. And the telescope is 5 times bigger in diameter than Hubble. So, and Hubble has seen deep into the universe. So you can imagine what James Webb will be able to do. We're really excited about that one. So the 4 science areas of NASA are Earth, Sun, Solar System, and Universe. And I try to keep up with all 4 of those things that are going on, although my own focus is the Earth.
That is exciting news. You're saying that we have landed a robot on Mars. You're saying that we are monitoring 35 projects just for Earth, 25 for the Sun, and 13 around the solar systems out there.
21 around the solar system, and 13 for everything else.
Oh, I can't even grasp what that means. Interesting. So tell us, if we go down then to Earth and climate change, as a scientist, how you started back many years ago to just help people to understand what's going on. What was the message back then, and how has that changed now today in the current situation that we're seeing?
So when I first started doing science research, it was not about earth science. I started out studying the way materials are put together, atoms and molecules inside crystals and things like that. And I ended up learning a lot about what's called quantum mechanics to do that. So my studies in school were mostly about quantum mechanics. Then I spent some time at the National Center for Atmospheric Research in Colorado, Boulder, Colorado, and started learning about climate. And when I first started doing it, it was just out of curiosity. You know, I just wanted to learn, why is the Earth this temperature, and how do clouds affect it, and so on. But then I learned that that was kind of a critical time. I was in Colorado in the 1970s, and in the 1970s, Earth had been cooling since the 1940s. So there was a peak warming in the 40s, and then between 1940 and 1970, Earth had been cooling off. So there was a lot of talk about ice ages and things. Are we going into another ice age? But then there was a realization around that time that CO2 is increasing, and that's going to be a bigger and bigger problem. We started monitoring carbon dioxide in 1957, which was called the International Geophysical Year. So in 1970, we'd been monitoring that for about a decade, a little bit more than a decade. And we saw that trend, that it goes up and down as the Earth breathes, but in general, it doesn't go down as far each year. And so there's a gradual increase. And the Earth, indeed, was forecast to start warming. Even though it had been cooling, the forecast was it's going to reverse that and begin warming. And sure enough, in the 1980s, and then even more in the 1990s, and then even more in the 2000s, and then even more in the 2010s, that's what happened. And now we've set several warming records since 1970, records in the 80s, 90s, 2000s, 2010s. The warmest year on record for the last 5 years has been 2016. But then this past year, we had a global average, yearly average temperature equal to 2016. So we tied the warmest year on record. So 5 of the warming years of record are in the last decade. And that's been the trend since then. Well, any one year could be cooler. For example, if the ocean is colder, something called La Nina happens in the ocean, and that can cool one year. But even when there's a relatively cool year these days, even that year is warmer than any of the cool years that happened in the 1970s when I started doing climate research. So it's like a new normal. You know, what is normal? Well, what we call cold today is not nearly as cold as we had in the 70s. When I first moved to Greenbelt, there's a small lake here about a block away from us, Greenbelt Lake. And my 2 sons would go play hockey on that lake. They'd get their ice skates out and their hockey puck and go out and with several of their friends, play hockey on that lake. Now the ice on that lake is never thick enough to skate on it. We're on thin ice. And I guess I'd say in more ways than one.
That is a vivid picture to understand climate change, just your personal experience as being a dad. How concerned are you in the situation that we are right now about global warming and the efforts that's being done?
Well, I on the one hand, I think global warming is one of two major challenges for the human species. The other being the possibility of nuclear holocaust on the planet. Nuclear holocaust could happen anytime the nations decide to press the button. You know, with the president we've had here for the last 4 years, until just recently, I was more worried about that than ever, to tell you the truth. To have a person who seemed unstable be in charge of whether to press that button. So that's a big concern. But I'd say equal to that is the concern of climate change. That happens more slowly. It's less dramatic because people sort of get used to it. They get used to the new normal. The best way to find out about climate change is to talk to an old person, you know, and say, what was it like when you were my age? This is what I tell all young people. Talk to the oldest person you know and just ask them, you know, like you're in Stockholm. What was Stockholm like 50 years ago? And they'll tell you it's not the same. So the question is, what will it be like 50 years from now? I won't be around then. You still will be. And you'll be telling the young people then how different it is today than it's going to be 50 years from now. And I think really how it is 50 years from now depends very much on what we do today. And by today, I mean in this decade. By 2030, we need to have stopped emitting carbon dioxide and other fossil fuels into our atmosphere, polluting our atmosphere. I think there's a little bit of an analogy with the development of cars. So 100 years ago, nobody had cars. Now it seems like everybody has them worldwide, right? 100 years ago, people got around in New York City driving horses around, and pulling wagons or buggies with people in them. And there were so many horses as population started to grow in New York City that the horse manure was piling up, and they had to shovel it in between the skyscrapers. And eventually there were piles of horse manure many stories high. And people had to put masks on to walk through New York City because it smelled so bad. But then the Model T Ford came out. That was the first affordable car in the early 1900s. And so everyone bought a Model T Ford, and they sold their horses. And they shipped the shit out of the city. And so the city got cleaned up, and people were driving cars, and that problem was solved. Today, I think it's kind of analogous to that, except that the shit is invisible, and it's in the air we breathe. So the question is, how are we going to change from emitting shit, namely burning coal? That's the primary. Secondary is oil and natural gas. How are we going to replace that with, say, solar energy and wind energy, geothermal, clean forms of energy? It's unfortunate that that CO2 is invisible. If we could see in 10 times longer wavelength, our eye sees only wavelengths that are what we call shortwave, visible light, which is shorter than a certain wavelength, what's called 700 nanometers. But CO2 is absorbing the kind of energy that Earth is trying to send out to space. So Earth is trying to keep cool by balancing the solar energy coming in. And that energy that goes out depends on Earth's temperature. And with Earth's temperature, the wavelength is around 10 times longer than what the eye can see. And so if your eye could see 15 microns, you would see the shit piling up. And I think we would have already done something about it. So we know what to do. We know how to switch over to solar and batteries and electric cars, electric airplanes, and so on. We know how to do it. The question is, are people going to want to do it?
That is the question. It's scary to think about these greenhouse gases. I've heard that they're staying in the atmosphere, some of them for 1,000 years, some for 100 years. And just knowing that they are there and just stacking up more and more and more. When I talk to people on this show, I speak to people who are tackling climate change from different angles. And I've identified 3 different problems. You're describing right now that we need to stop the emissions. That would be one problem to solve. Another problem would be how to extract those emissions from the atmosphere. That is new technology. And one problem that many people are working with is how to preserve nature so that nature in itself can absorb as well.
And these problems are connected because one of the best technologies for extracting CO2 from the atmosphere is called a tree.
Right.
And some of the best trees for doing that are in the Amazon. So you might think, gee, we're probably planting a lot more trees in the Amazon, right? Yeah. Unfortunately, no. We're cutting them down, not planting them. So that needs to get reversed. And land use, the way we use our land and our trees needs to keep in mind what those trees and other species growing on the land are doing for us.
I was going to ask you, so you've been talking about we need to have the political will to change the system. Where would you put your focus today, or where are you putting your focus on what problem when it comes to climate change?
So one thing I would say is there's no magic bullet. You know, like what people want is they want one thing. If I could just do one thing and fix it, like invent the Model T Ford car. But climate change isn't like that. And what we need is to be doing 100 things, and they're all interrelated. A good way to find out what those 100 things are is to go to the website on Drawdown. Drawdown is a project that has studied 100 different things, all of which could go in the right direction to solve climate change. And they've given a measure of the impact of each of those 100 things. And what I like about that is that they don't end up concluding that, well, this one wins, and therefore we should all do that. You know, the conclusion is there's 100 things. They're all good things to do. Many of them can be done at the same time because of, like I said, planting a tree is doing 2 of the things that you mentioned, both at the same time. I like it because anyone on the planet can find something in the list of 100 that they can do. So it's really something we can all do. So I think part of it is what individuals choose to do. And part of it is political on the largest scale. I mean, we need to get our local towns. I've been talking to our one of our mayors of my little town to go on record as supporting Drawdown. And there's another website, newer, called Countdown, which supports all the goals of Drawdown, but has more of a time scale focus. In other words, Countdown, we're counting down to 2030. We need to have changed things by 2030. That's the time scale. We have 9 years now. The pandemic has slowed us down a bit in doing that on the one hand. On the other hand, because people haven't been getting out and flying all around, the pandemic has actually helped us a little bit. Not because we intended it to, but because We just haven't been able to get out because we don't want to die. Actually, I'm eager to get out more now that I've been vaccinated. But when we change back to the pre-pandemic times, we don't want to be doing all the same things. I don't want. I have an all-electric car which runs off my solar panels, so I'm a little more comfortable getting out and driving that around. But I'm going to be more hesitant to get on a jet airplane to fly somewhere because of its emissions. So we need those local, individual, or small group efforts, but we also need efforts all the way up to globally coordinated, like trade between countries like Australia and China. Much of the coal that's burned in China comes from Australia. So there needs to be an agreement between those two countries to restrict the use of coal, or at least new coal. They could set a standard for what they're doing now and say, let's try to be doing less of that and changing that with other trade by 2030. And there are other examples.
So you're saying when you look at the emissions of specific countries like China, you see that they have a lot of emissions, but then that is actually because there's a demand from other countries. So
exactly,
it's all intervened in. We need to solve it on a global level anyway.
Exactly.
Yeah, that makes sense. We are getting towards the end there, and I do want to leave some time for you to get back at speaking about more about the work that NASA is doing. And if you start by helping the audience and myself to understand, is there any place at the website of NASA that you want people to look for trustworthy resources, or something that you want people to know about that NASA is currently doing studies about?
I think, as we talked about, the part of the problem with global warming is the will to do it. And I think part of the lack of will comes from the feeling people have of being powerless. People feel that they cannot make a difference. And I've been trying to sort of struggle against that by giving a talk that gives reasons for hope. It's a little bit tricky, the thing about hope, because you don't want to give false hope, right? You want to give realistic reasons for hope. And those do exist, but they exist alongside false stories that are being spread around about that we don't need to do this or do that. So I do have a talk online. I think I sent you a link to it that talks about some reasons for hope. They're my reasons, and other people may have different reasons. One of my reasons, I have to say, and maybe this is a bit because I'm a scientist, but one of my reasons for hope, and this may seem strange, but it is that we know so much more today than, say, 100 years ago about what we don't know. And I'll give one example of that. When I went to school and learned chemistry, I was shown the periodic table of the elements. And my chemistry teacher, and they still do this today, they say, you see these 100 or so elements, everything in the universe is made out of those. So they're all made out of hydrogen, helium, lithium, beryllium, carbon, nitrogen, so on. Well, today we know that isn't true. Isn't that interesting? That's not true. In fact, there's 5 times as much stuff out there, material, that doesn't come from the periodic table of the elements. So 5 times the matter in the universe is made of something else. We don't know what that is. We have guesses. One scientist colleague of mine believes it comes from a particle called the axion, but nobody really knows. And there are about 12 different ideas about what it could be. But right now, we don't know what it is. So first thing, I find that humbling. I mean, it should be humbling. You know, humans shouldn't be so arrogant to think they know everything these days. We don't. And so that means we have a lot of work to do to get smarter. And there's a lot of room to get smarter, because we don't even know what most of the universe is made out of. We used to think it was mostly hydrogen. Well, hydrogen is the most common element out in the universe, the elements being from the periodic table, but it's not the most common material. And the material that the universe is made out of is transparent. They call it dark matter, but that's a bad name for it. They should call it transparent matter. It's invisible. We can't see it, but we see its gravitational effects. Galaxies would fly apart if they weren't mostly made out of dark matter. And so it has dramatic effects. So I find that one realistic reason for hope, that if we keep learning, we're going to easily find our way out of these problems that seem insoluble today, like global warming is one of them. And the other is, how are we going to deal with nuclear matter without blowing our planet up and destroying life on Earth? And I think there are ways to do that. And we need to keep educating ourselves. My wife works in education, so what she does is more important than what I do, because she's helping people learn.
I almost see a picture of a child. If a child is trying to envision life from the child's perspective, it's so hard to know what life is going to be. But as you grow, you start to feel like the problems you had as a child is not as much of a problem.
Exactly.
So it's similar to what you're saying, that we are, as a society, maybe a child.
And I always point to children, as you say, young children. When I teach classes of fifth graders, I'll be having a Zoom call on Wednesday with a fifth grade class up in New Rochelle, New York. And when I talk to fifth graders, I ask them here in the United States, I say, how many of you know English? And they look kind of confused. And then, of course, they all put up their hands. Oh, we all know English. And then I said, well, how did you learn that? Did you study in a book, or how did you first starting speaking English? And I said, I don't know. I was really young. I don't remember how I started speaking English. I just seemed to be able to start doing it. And I said, so what that tells you is the smartest learners, the best learners, are the little babies. So if you want to know how to learn, watch the babies. They're learning. They are like sponges. They're absorbing knowledge. They use many different methods. Imitation is one of their methods, but making a lot of mistakes, that's another one. They're not bothered by their mistakes. They're not embarrassed. And they ask questions. When they get to be 2 years old, they just start pestering you with one question after another. So, yeah, we should all try to be like babies.
And that would give us even more motivation to why we should preserve Earth, because then next generation will get to
exactly.
We are getting towards the end here, and I want you to get the chance to kind of actually, before I leave the space to you, I just want to let people know drawdown.org you can go to, nasa.government or science.nasa.government, I guess would be. And is there any specific kind of message? You and I spoke about the inspiration from Kennedy.
Yes.
That was interesting to hear your perspective. Is there any specific message that you would like to leave the audience with in this interview?
Yeah, one of the most inspiring speeches I think you can read online is President John F. Kennedy's speech about going to the moon, which he gave in 1962. And the part that's usually quoted from that is, we want to go to the moon not because it's easy, but because it's hard. And it's the same reason that people wanted to climb Mount Everest before that was first done. They asked the person who first climbed that. Of course, they usually mention the English person, but there was also the person who was carrying that English person's luggage, so to speak, up Mount Everest. Tenzing, his name was. And the answer was because it's there. And I think that was, Kennedy said, we want to go to the moon because it's there. We want to have space travel because space is there. You know, look out into space. And then when we get out into space, we look back at the Earth. It's a way to really see ourselves for who we are. Of course, back when I started this thing, there was no such thing as Star Trek. Now there are many shows that show what it might be like out in space, but we really don't know because we've not been very far from our home yet. One of the fifth grade students sent in a question, the ones I'll be meeting with on Wednesday. What would happen if when the Earth explodes and when the sun explodes, what if there are still people on Earth? What would happen to them? And my answer to them is going to be, well, if we're still here on Earth when the sun explodes, we will all be vaporized. So that's a problem. And the solution is not going to be easy because we're going to have to know how to travel to other stars, where now we know now most other stars have planets. And most of those have planets that have a reasonable temperature. So there are other ways to go, but the stars are very distant. And right now we have no idea how to travel those kind of distances. But we have 1 billion years to figure that out, 1,000 million years. So if we get started now, first let's solve global warming, then let's solve nuclear weapons, get rid of those. We can do other nuclear things, but we don't want nuclear weapons. And then we'll get smarter and smarter, and eventually we'll know how to go to the stars.
Beautiful. Thank you very much for taking time here, Robert, and tapping into your wisdom. I do feel more hope just hearing you speak about the future and speak about history, actually.
Yeah, and I just wanted to mention that as I mentioned to you earlier, Spirit, that I'm reading a book about Julian of Norwich, who lived in the 1100s. So here we are in the 2020s. So this was like 900 years ago. And there was the Black Death then, and there were no vaccinations. And but Julian of Norwich found a way to be hopeful. So I think hope is really what we have to live on. And even in hopeless times, we have to find reasons for hope.